All right, welcome back. Let's go ahead and see what we got, you wonderful people. So we're going back and doing the systems of three equations. So we didn't really finish it the last time because we got through a lot of the equation parts. So we did the we did the equations, right? So again, you got to have three variables, and you can solve it using either multiplication or sometimes called the elimination method. Sometimes you can also use the substitution method as well. So that we're going to focus on this one here. And again, this is from an older packet, and we're going back on it. So just so that way we can get our required classes done. So this is probably the ones that you remember doing. And again, I think there's 2 packets that this comes in. You only need to do it once, and this only counts for the attendance for Monday and Wednesday of this week, week 9. So let's go ahead and get started with what we're looking at now. And let's see, we have our first question, first problem, first exercise. So the theater sells 3 types of tickets. So general admission, senior citizen, and child. All right, so great introduction statement. It introduces us to all of our variables. So let's go ahead and put those in and assign them. So X, Y, and Z. So Z equals here. And then X is going to be general, so we'll call that general. And Y, the next thing they mentioned after that was senior citizen. It's senior, okay, that's how you spell it, yeah. And then last one they mentioned was child, so we're just gonna go in order of how they mentioned it. So this would be child ticket. Okay, I'm gonna write that down. Now it's time to set up our equations. So we're gonna have to do this ourselves. So again, we have introduction, and now we should have our, what I call the clue statements or the body statements. So that's like the actual stuff that we're looking for, the actual stuff that we need to get. So first one we have is a guy, Mark. So it says he bought 9 general admission, 2 senior citizen, and 3 child tickets, and paid $170. All right, that makes it really easy to find that was one of the first statements, and it even makes it a little bit easier because it names a second person. So Sarah bought 5 general admission, and 4 senior citizen, and 7 child tickets, and that was $173. And then our third person here, Kyle, bought 4 general admission, so 4X plus 1 senior citizen, so 1Y, and 6 child tickets. And this was $116, oops, and 50 cents. So pretty easy to set up, nothing really that difficult about this one here. In fact, this one, very straightforward. You know, there's nothing that would really be confusing. Okay, so now the next thing we have to do, and let's just go ahead and do a really quick review on, how we do this here. So choose 2 equations. So we have 2 equations. So this is, one set. We eliminate 1 variable and we call that equation A. And now using a different combination, so a different set for step number 2, we eliminate that same variable and we'll call that one equation B. So take your equation in A and B, and then you should be able to eliminate 1 more, so that way you'll have 1 variable. Take that 1 variable, plug it into one of the other ones that you've used, and that should give you 2 of them. Then take those 2, plug it back into one of the original equations, and that should get you all 3 of your variables. And write your solution as an ordered triple. So it's like an ordered pair, but instead of X and Y, this one also includes Z. So we set it up. Now let's go ahead and go back to this one and choose 2 equations. And let's see, we got to pick one of the variables to eliminate. So before we even pick 2 equations, we want to eliminate one of the variables. So just a quick reminder on how we pick some of these. So if we look at X, so if I pick these 2 to eliminate X, I would have to make both numbers into 45, which would mean I'd have to multiply the top number by 5 and the bottom number by the bottom equation by 9. So I'd have to multiply both of them. And if I did these two here for x, I'd have to make them both into 20x. That would mean multiply this middle one by 4 and the bottom one by 5. And again, that's a little bit of work. Here, if I were to eliminate z, I'd have to make both of these something like 42. And that means I'd have to multiply both of them. If I were to do this one here, I'd have to make both of them 21, which again means I'd have to multiply both of them. And if you remember, I like to keep as many things the same as I can. So could you do any of those combinations? Yeah, you will still get the right answer. But again, let's keep things simple because again, as I find it, the more things you change, the greater there will be a chance that something is going to go wrong. So I think y is going to be the best combination to pick. Because in this case, I only have to double the top one and I'll get 4y on both of these. And then if I were to pick in this one or this one, you know, this one y makes things really easy because since there's only one, I can multiply this by either 4 or multiply it by 2 and get matching y's. So I think that's probably, probably the best way to do that. All right, so definitely I'm going to pick the top two. And it's not going to quite work out because I am going to need to make this one doubled. So I'm going to double this one. So I'm going to put a 2 on that line. That way, if I ever need to check my work, I can you know, follow the lines back to where any errors would happen. It also helps organize your thoughts so that you don't have to, you know, it also decreases the chances of something going wrong. All right, so first one, let's double all of the top numbers. So I'm going to double everything. 6z equals, and then this would be, let's see, I'm pretty sure it's 340. So 170 times 2 is 340. Yep. All right, so everything got doubled. Looking it over, making sure everything got doubled. Looks okay to me. Now let's go ahead and do that second equation. So in this case here, I'm just going to change everything into a negative. So everything changes to a negative. 7z equals negative 173. So make sure all the signs are changed and make sure I didn't change anything other than the signs. And that makes it pretty straightforward. Let me go ahead and take this and subtract what we have. So again, we're going to eliminate y, which it looks like y is going to eliminate, which is good. So 18 minus 5 would be 13. And then minus z equals 340 minus 173, and that's going to be 167. So there we go. We eliminated y from there. Now we need to eliminate y from a second set. And let's see. I want to keep this bottom one, definitely. Bottom one's a really good one. The question is, what do I do with, which of the top ones do I pick? I kind of want to pick this top one here. That way I would only have to double it. So I'm going to make this one opposite, and I'm going to double this one here. Because again, the y's need a match, so they both have to be 2y, but then they also have to have one of them be negative. So instead of changing two things at a time, I'm going to just change one thing at a time. So this is going to be, let's see, negative 9x. And then minus 2y minus 3z equals negative 170. And now I'm going to do the same thing with the bottom one, but I'm going to double both numbers. So that's going to be 8x plus 2y. And that's good because now I can look at my y's and see that they are going to be able to be eliminated fairly easily. And then 11650 times 2, and that's going to be 233. Okay, and then check the signs. It's just a good habit to check your signs, make sure that we're not, changing anything that doesn't need to be changed. All right, so let's go ahead and combine these two now. All right, so this would be negative x. Makes it kind of easy because you want these numbers to be as low as possible. Plus 9y, oops, 9y, because, z, because y cancels. So I'm looking at 12 minus 3, z, so that would be 9z. And then 233 minus 170, that's going to be 63. All right, not bad. Now I got to take my equation A and my equation B and combine those in a way that will eliminate one more of them. So let me think, which one should I solve for? Because in a way, it's both. They're both kind of easy because, well, x's and z's are opposites. Both of them have one positive and one negative in each one. So I guess the question I should be asking is it easier to multiply my equation A by 9, or would it be easier to multiply this one by, say, 13? I think I'm going to go with this one and multiply it by 13. And there's my mouse acting up again. I'm not sure why it's doing that. So let's go ahead and multiply everything by 13. Okay, 9 times 13. It'd be 117. Z, and then 63 times 13. That would be 8. Make sure I'm reading this right. 819. Don't want to accidentally put something like 879 there. And then for this one here, I think we're able to just leave this one the same. In other words, I don't need to change anything because if you look at it, it's already, the x is already set to eliminate. And let's go ahead and put these two together. All right, and this will be our, I don't know what you'd call this, equation C or something. All right, so 117 minus 1, it's going to be 116. And Z equals 819 plus 167. It's going to be 986. And I'm going to divide both of them by 116. So again, I'm just going to be doing some basic algebra stuff. And it says here that the Z, which is, what is Z? Z is child ticket. It's going to be $8.50. So again, we got our first solution, and we just need the other two. So we know that the child tickets are $8.50. So we're going to take one of these and plug it into either this one or this one. In fact, I'm going to plug it into this one here, 13x minus z, but instead of z, we're going to plug in 8.5. And again, the 8.5 comes from here. And this should give us the number of x, which is general tickets. The general, I don't know what you'd call it, general population, general, general population. All right, so, well, in this case, I'm going to get rid of these parentheses. Hopefully you can kind of see where the number came from by now. So I'm going to have to take 167, And I'm probably going to add 8.5 to both sides. So that's going to be 13x equals 17550. And then I'm going to divide that by 13, and it should give me hopefully a good number. Now remember, these are dollar amounts. So in this case, I got 13.5 or $13.50. That seems like a pretty okay price for a ticket. It says the theater. I don't know what kind of theater it could be. So when you say theater, you know, it's a movie theater. But $13 seems kind of expensive for a movie theater ticket. So maybe this is something else, like a Broadway play or something. Who knows? And there we go. So we got the X now. We got the general ticket. So now we need to find out how much a senior ticket would cost. So a senior ticket in this case here, let's see. I want to use this one here. This is probably going to be the best one because Y is already solved for. It's already solved for Y. So I'm going to use that one. I'm going to use this last one. So I'm going to plug in the other two numbers that I got. So 4x. So 4x, and I know here that x is 1350. So we're looking at that last person, that Kyle. He bought 4 tickets for the general, and that's $13.50 a piece, plus one of the seniors, and 6 children tickets. So he bought 6 children tickets, and each one was $8.50. And his total came out to 116.5. Oopsie. Hope I just need to get all that to fit in there now. All right, so 1350 times 4, and that's going to be 54, plus Y plus 6 times 8.5, that's going to be 51, equals 116.5. And you can't really see the 0.5 because it's just barely off screen there. And combine like terms, so I'm going to add 51 and 54 together, so we get 105 plus Y equals, plus Y. There you go, 116.5. And then I'm going to have to divide both sides by 105. Does that seem right? No. Oh, okay. I see. I'm not dividing. I'm not dividing because I thought if I divided, that'd be like $1 a ticket pretty much. And in this case here, we got 1150 is what it looks like. So Y equals 1150. And just from what you know, if you, whatever you do, sometimes you go to like a buffet, or in this case, a movie theater, they almost always have different prices for different people, for seniors and children and all that stuff. So $11.50 for a senior does not seem really unlikely. These all seem like likely prices, right? And again, that's just something that's good to do with any kind of word problem you're working on, is just give it what I call the sniff test. If something doesn't seem right, then check your work, make sure that nothing's completely wrong or off or anything like that, because $8 for a child ticket, 11 for a senior, and 13 for general, that seems pretty likely, I guess. It's a little bit expensive, but works out. The last thing we got to do is put it into an ordered triple. So start with X. I didn't start with X. So 1350 for the first one, 1150 for the second one, and the last one is 8.5. So place the answer into an ordered triple, and we are done with that. Make that box a little better. Yeah, okay, enough. All right, so that's one down. Let's go ahead and move on to the next one. Here we go. Oops. All right, let's see. Next question. I don't know if this is Jamie or Jaime. Has a collection of 78 nickels, dimes, and quarters worth $12.40. Okay, that's pretty straightforward. introduction statement, and the body statement here says if the number of quarters doubled, the value becomes $22.15. How many of each type of coin does Jamie have? Okay, that seems kind of weird because there's only 2 sentences that have numbers in them. So that last one was very straightforward. This, some of these you will have to do a little bit of thinking about. So let's go ahead and again, just start with what we know. So we know there should be 3 things because that's what the assignment says. There are 3 things that we are looking for. So there's an X, a Y, and a Z, and we need to assign something to each of these. So it mentions nickels as the first thing. And then the second thing it mentions is dimes. And the last thing it mentions is quatas. There we go. All right, so that's the first thing. Identify our variables. And it's kind of all over the place. If you look at it here, it says he has a collection of 78 nickels, dimes, and quarters. 78 nickels, dimes, and quarters. So again, it's the same sentence, and I think what most people might do is they might want to put the 1240 and the 78 together in the same sentence in the same equation, but that's not really necessary. So again, the first one is the number. So keep your numbers and your values separate. I'm sorry, the quantity. So in this case, the first one they say is the quantity. So if you're just counting the number of dimes, number of nickels, and number of quarters, then you get 78. All right, because again, it doesn't matter how many you have or how much they're worth. 1 dime is 1 dime, 4 nickels is 4 nickels, and so forth. It doesn't change. And again, this one's a tricky one because it says it's also worth $12.40. So in this case here, it's kind of hidden because this is one of them that you're going to do a little bit of extra reading in, because now you're going to have to put in your nickels and assign the value to your dimes and your quarters. And that comes out to $12.40. And I'm going to just sort of level these out a little bit. That way they're not so all over the place. So that first sentence actually had the introduction and 2 of the clue statement. So there's 3 things in this little short sentence right here. All right, now this one's a little bit of a tricky one because when I first read this, I was like, what does it mean by this? So it says the number of quarters is, if it's doubled, the value becomes $22.15. And I sat there and thought, okay, what does this mean? The number of quarters is doubled, because even if I double, like let's say every quarter is now worth 50 cents, because if we double the number of quarters, does that mean it includes still the nickels and dimes? So yeah, okay, so you keep everything the same, because you know $12 and then the jump to $22 would be like $10. That'd be like 40 quarters, which I don't know if that's plausible or not, but that just seems like a really high leap. So what I'm going to do is I'm going to double again this number. So if you double the number of quarters, you know, well, if you double the number of quarters, it would be like doubling the number of quarters, but you could also double the value. If you were to say each quarter is now worth 50 cents, it would mean the same thing, but that would also change the value of the total coins from $12.40 to $22.15. Okay, so now we have our 3 equations, and remember, every one of these need to have 3 equations. So next thing we need to do is pick some of them. Now, definitely, I want these 2 together. Okay, I want these because the bottom 2, if I look at them, they're almost identical. They're almost identical. And in fact, actually, there is kind of something that's going to happen that's going to be a bit of a weird thing here. And I might do this one first. So I'm gonna times the top one by -1. Times the top one by -1. So that's going to reverse all of the all of the values here. But it's also going to change the sign, so they're all going to be negative now. So all of the signs are going to change to a negative. And usually, for me, when I pick which one's going to be negative, I usually want the one that's lower. So 1240 is a smaller number. So when I subtract 1240 from 2215, it will stay a positive number. Okay, now I'm going to do the same thing with the bottom one, and everything's going to stay the same. It's going to be 50, and I'm going to change this to 2215. There we go. So now I think it's ready to eliminate. So we can eliminate one of the variables. Now, again, something interesting happens here because 5 cents minus 5 cents is going to be nothing. 10 cents minus 10 cents is going to be nothing. Okay, so 50 minus 25. Okay, so it's going to be positive because my positive number is bigger. And we know that if you take 50 cents and minus 25 cents, you're going to have 25 cents left over. And then here I have 22.15 minus $12.40, and that'd be $9.75. And if you told me that you had $9.75 in quarters, I would believe that. Well, probably be more likely to believe it because, well, that kind of makes sense that you can get $9.75 in quarters, but you can't get something like $3.63 in quarters. And then divide both sides by 25, which would probably be like 39 because I know 40 quarters is $10. In fact, I'm pretty sure that is what it is. Yeah, it's 39. So Z is the number of quarters. So we're actually, normally we would have to do an equation A and an equation B in order to get one variable. But this one was actually really good because, we only did one of them and we already got one of them. We already know now that Z, or the number of quarters, is 39. Okay, but I don't know how much this actually helps us because we're gonna have to find one more of these. So I'm gonna pick a different combination. And again, I picked these bottom two first because to me, it just looked like it was a real easy thing to do, to just get the bottom numbers, because again, both equations are almost identical. So I'm gonna have to use this top one somewhere. I'm gonna have to use this top one somewhere. And that means I'm also gonna have to pick one of the bottom ones. And I'm gonna pick this one here just because it's got the smaller numbers. Now I gotta pick one, either X or Y, to eliminate. Actually, you know what? I'm gonna eliminate Z. Wait, should I eliminate? Okay, so hold on. Well, actually, no, I don't need to eliminate Z because I already know what Z is gonna be. I know that Z is gonna be 39, so I just plug that in. So I would need to eliminate definitely X or Y. Definitely X or Y. And I'm gonna eliminate X. So I'm gonna times this whole top equation by 0.5. Now, okay, let's see what we get. And that's pretty easy because if you look at that top equation, everything is already 1. It's already X, Y, and Z. All right, so 78 times 0.5, and that'd be 3.9. And while I'm at it, I'm also going to make everything negative because, again, this is going to cancel. And if I multiply this bottom one by -1, that's going to make it negative, which, again, you're going to get the right answer. But just to make things a little bit easier while I'm here, I'm going to reverse the sign on all of these right now. So that's going to be a negative. That's going to be a negative. That's going to be a negative. And that's going to be a negative. So, okay. made it a little bit easy because now I don't have to do a whole lot of anything. And this bottom one here, I can just leave this bottom one exactly the same. I don't have to change anything. And again, as you change more things, you raise the risk of changing something without meaning to, which is what makes this bottom one good, because I don't have to change anything on it at all. And this should allow me to get X, or in this case, I'm going to eliminate X. Okay, and eliminate X, that's going to be gone. And here I'm going to have, well, 10 cents minus 5 cents. 10 cents minus 5 cents would be 5 cents. And let's see, 50 cents minus 5 cents also. So 50 cents minus 5 cents, that'd be 45 cents. And let's see, 22.15 minus 3.9, and that would be 18.25. Okay. Now I need to take my Z, because we know what the Z is. Okay, we know what the Z is. Let's plug it in and see what we get. Okay, so I'm gonna plug it in. I'm gonna write it over here. In fact, you know, I'm just gonna copy it. That's one good thing about typing all. Oops, wrong one. Grab the wrong thing. There we go. And we know that Z is 39 now. So I'm gonna plug in Z as 39. And this will allow us, because now we don't have to do a whole nother equation and plug in two things and, you know, all this stuff here. It's going by a little bit faster because now we're able to just like plug some of this in. Okay, so we know Z is 39, so we plug that in. So 45 cents times 39, that's going to be 17.55. Nothing's changed here. 17.55 equals 18.25. Okay. Now I'm gonna have to minus, we're gonna have to minus 17.55 on both sides, so that way we can get that Y by itself. So 0.7. I guess that, is it really only 70 cents difference? Yeah, I guess that looks plausible. So in this case here, Y is the number of dimes. So let's see if this is very likely. And that would be 14. So in this case here, we have 14 dimes. And I guess that's what it is. It is what it is. Now, if we know that we have 14 dimes and 39 quarters, we can go back to one of the originals. And I like using that top one. That top one's a really good one, because I am going to plug it in over here. And let's see what we get. So X, we don't know what X is. We don't know how many nickels there are. But we do know there are 14 dimes, and there should be 39 quarters, and that comes out to 78 coins in total. So 78, and I can add these together. So minus 39, that would be 70, oh, hold on, 78 minus 14, and that would be 64. So X plus 39 equals 64. And then I'm gonna minus 39 from both sides as well, so that we get 25. So 25 nickels, X equals 25. And again, just some basic algebra. You know, I know it's not the best way to show this, but it's just again doing the same thing to both sides. And typing it's a lot easier to see, and there's, you know, less chance that a 5 is going to be mistaken for like an S or something, or a Z is going to be mistaken for a 2. So typing it's usually just a better way of showing the answer. Last thing, let's go ahead and put our answer into an ordered triple. So start with X, Y, and Z. So X in this case is 25. Y is 14. So that's our second number. And Z is 39. So that's the last number there. And it looks like we've managed to finish another one. So we got this one. And again, this one was a little bit faster than a normal one, because if this was a normal 3 variable systems of equations, probably would have taken a little bit longer because you'd have to do 2 whole equations. But you notice this one's not as cluttered. It doesn't have as much stuff on it as the other ones. Whew, okay. All right, so I guess we're ready to move on to the next one. Hopefully you got this one written down. So we're moving on to the next one. All right, so another one with stamps. Mason has a collection of 49-cent stamps, 20-cent stamps, and 3-cent stamps worth $23.55. He has a total of 49 cents. I'm sorry, he has 56 total, 49-cent stamps and 20-cent stamps, and the number of 3-cent stamps is 9 more than the number of 20-cent stamps. How many of each does he have? Okay, so that one made my brain overheat just reading it. So unlike the first one, that was easy to put together, this one here looks like it's got a lot of stuff going on. But again, remember, there are 3 variables and 3 equations. So first off, easiest thing to do, let's go ahead and identify what we're working with. So we need to assign something to x, something to y, and something to z. So the first thing they mentioned are the 49-cent stamps, and I'm going to turn it into a dollar amount. And then y is going to be the 20-cent stamps, so I'm going to turn that into a dollar amount. And then the last one is the 3-cent pieces, so those are going to be z. Okay, so looking at it here, it mentions, let's see, first statement is also a clue, but it's also the introduction. Okay, so it has a collection of these stamps, and they are worth $23.55. So let's add the value of the stamps together. Oops. And that should come out to $23.55. Okay, next equation here. It says he has 56 total 49 and 20-cent stamps. And the number of 3-cent stamps is 9 more than the number of 20-cent stamps. So that's one big long sentence. And this one's tricky for another reason, because if you know anything about English, I think these are called conjunctions. So like when you connect one idea to another idea, or one sentence to another sentence, you would say like and, but, however, or something like that, right? So there's connecting words where you connect 2 ideas. And this one's kind of a tricky one because, again, there's 2 of them. So it's not, I don't know if it's grammatically correct or not. But I had to kind of read this a few times and be like, okay, what's going on with this here? So first one here, it says he has 56 total of the 49 and 20-cent stamps. So we need 3 equations, right? So 3 equations. 56 of the 49 cents. So we're talking about the number of stamps, not their value. And the 20-cent stamps. So the number of the x and the number of the y should come out to 56. And the second and is actually starting the new, it's like you could break a sentence right there. Take that second and out, put a period in there, and it would read even better. So it'd say the number of 3-cent stamps, the number of the 3-cent stamps, so z. Oh, and every time you're reading a word problem, when you're putting it into an algebraic statement, words like is, was, and words like that, those are the equal sign. So when it says here 3-cent stamps is, so that's is 9 more than the number of 20-cent stamps. So the number of 20-cent stamps is y. Y represents the 20-cent stamps because right there we identified it. So however many of the 20 cents he has, there'll be 9 more of the 3 cents. So like example, if he had 10 of the 20-cent stamps, if he had 10, that would mean he'd have 19 of the 3-cent stamps. So this one looks like it's ready to go. And this one's another tricky one because, well, looking at it, gosh, where do we begin? So all of these are not in the same order. The top one is X, Y, Z. The bottom one is, you know, number equals X and Y. And the bottom one, or did I say bottom one or middle one? The middle one is 56 and X and Y. And then the bottom one is Z is 9 and Y. So this one's kind of a confusing one because it's like where to begin. So what we could do is pick one of these. So we need either X, Y, or Z to become, so what we want is we want this one, or this one to all become one variable. So we're going to try to use substitution since it looks like these bottom ones can be easily solved for X, Y, or Z. So this bottom one is good, actually. I think this bottom one, we don't need to change anything because we're going to plug it in right there. So this means that I would need to solve this one for X or Y. Need to solve it for X or Y. Now the question is, which one do I want? Do I want to have to, I don't like the 49. And again, I could pick either one. I could pick this one and solve it for X or Y. But I don't want that 49 there. So I'm going to get rid of the 49. And again, you can do either way, both ways, doesn't matter. I want to plug in something for X. So this means I'm going to rewrite this equation for X. So X equals, and I'm just going to minus Y from both sides, 56 minus Y. So again, just minus Y, you get 56 minus Y on this side, and then use reflexive property and just switch the side that they're on. Okay, so again, this one's kind of a confusing one, and don't worry, I have to think about it a little too. And what this allows me to do is it allows me to plug in to this top one. So we know that X is going to be 56 minus Y. Right, and I'm going to color code it just so it's a little bit easier to pick out. And then Z here is going to be on the bottom one, the bottom equation. We know that Z is equal to 9 plus Y. Now, if you look at the new statement that we created, the new equation, it's all Y, right? Y here, Y there, Y here. So I have 3 Ys. They all became Y. And that's a good thing. Because when you substitute, you want to make sure that you get rid of all the other ones. Now, this is a good thing because once I evaluate this, we can solve for Y very easily. All right, but we will need I'm going to need a calculator in this case. So 0.49 times 56, and that's going to be 27. So 2744 minus 0.49y plus 0.02y plus, and then here I'm going to have to multiply using distributive property. So 9 times 0.03, and that'd be 0.27 plus 0.03y, and this all should come out to 2355. So I got a lot of y stuff going on, and I'm gonna have to combine all my y's together. So let's see, I have 20 cents in y and 3 cents in y. So this one and this one. I'm going to do my positives first. So that's going to be 0.23 in y. So again, this one and that one. And I'm going to have to minus 0.49. So in this case, I get negative 0.26 y. And that takes care of all my y values. Now I'm going to have to take care of the regular numbers. So 27.44, the very first number, add that to 0.27 cents, and that's going to be 27.71 equals 23.55. Okay, and I think we are ready on this one here. So I'm going to go ahead and minus 27.71 from both sides. And we get 416, so this stays the same. 4.16. And that's actually going to be a negative. Again, my calculator does not keep track of negatives. So anytime there's going to be a sign change, I have to kind of think about it. I have to keep it in my head. So 23, so minus 27 from 23, yeah, that's going to be a negative number. And divide this by 0.26, which I don't have to worry about the negative because negative divided by negative should be positive. And I should get my first value. So in this case, y equals 16. So for the middle priced stamps, the 20-cent stamps, we got 16 of them. All right, good, we got it. So next thing we need to do is take one of these equations, and I can use the original in this case. This is a good idea to use the original because in this case, look at that. We already have y by itself, and x is already by itself. So if I just solve this, I should be able to get x pretty easily. So again, take y and replace it with 16. Because that middle statement says he has a total of 56 of the 49 and 20-cent stamps. So 56 minus 16, that's going to be 40. So we know that x, or the 49 cent stamps would be the 40 of those. And that makes it pretty easy. So now we have x, now we have y, so now we need z. So if you look at this bottom equation, that one's already solved for z already. We don't need anything else. So I'm going to take this one and let's plug in z. So, well, we're not plugging in z, we're plugging in to get z. So 9 plus y. But if we look down, y is 16. And again, this one's very different from most of the other ones we've worked on up to this point. So 9 and 16, pretty sure that's going to be 25. And that looks okay. We got all of them. So these ones, I think they may require a little bit more thinking to get through. But largely, work-wise, there's not a whole lot of work. Once you get one of them, the other two, in this case, we got those pretty easily. But again, setting them up is one of the parts I'm kind of worried about people getting stuck on. So there we go. We got that and box that up. Our ordered triple, and we are done with another one. All right, so let's get ready for the next one. So how am I doing on time? Okay, not too bad. Okay, number 9. Oh, and the numbering on your packet's probably not going to match exactly, so be careful about that, okay? You probably already figured it out if you haven't said anything about it yet. All right, so 3 medals earned in the Olympics are the gold, silver, and bronze medals. All right, so that's good. We already know we can already set up our clue statements. Our variables, and then we'll move into the clue statements. So in this one, the introduction is pretty good. So we'll have this one for gold, silver, and bronze. All right, now setting up the clue. So in the 2014, that's not really important. 2014 is not necessary. In this case, it's just telling us when it happened. The United States had 28 total medal winners. Now every medal is worth the same amount. So it's not like gold is worth this much and silver is worth another amount. So in this first one here, we have X, Y, and Z, and this is just the total number of medals right now. Now there were 2 more Okay, so the second statement says there were 2 more gold medals than silver medals. And the number of bronze medals was 4 less than the sum of the number of gold and silver. How many were each of these type of medals? So this is our question statement. They want us to know and list each of the number of medals. So that means that this one here actually has 2 of them together. And then again, and is where you would find the difference. And this and is kind of a tricky one because and can also mean plus, right? So like, you know, I have, you know, 3 pencils, right? And I get 2 more, right? So that'd be like an example of plus being used as an operator or an addition sign. But in this case here, and should separate these 2 sentences. So if we look at these 2 sentences, and again, there should be 3 equations. So there were, so there's the equals, 2 more gold medals. So there's more gold than silver. So thinking about it, okay, so if there were 10 silver medals, there would be 12 gold. So there's 2 more of the gold than the silver. Okay, so that works out. And again, this and here is a throw off because if it was trying to be easy to read, it would have a period instead of an and. The number of bronze medals, so the number of bronze, so Z equals, was, so bronze was, and again, was and is are, or anything that kind of like explains, you know, what something is or was, those are equal signs, was 4 less than the sum of gold and silver, so X and Y. Now be careful, because again, less than is one of the very few tricky ones when it comes to algebraic translations, because when you say the word less than, remember that it means you are lessening something by that amount. All right, so like if you had $4 less than your friend, that means if your friend had $10, you have $6, right? So again, that is a tricky one. So I imagine a lot of people would probably set it up like that, but really it's supposed to be set up like this. And actually these should be in a parenthesis, because whenever you see the word sum, difference, quotient, or product, that means that they are in parentheses. But in this case, we don't really need to worry about it because we're not multiplying anything and we're not substituting anything in there. So we could do this without the parentheses, and it would still kind of work. All right, so setting it up, that one was a bit of a chore, a little bit of a headache, but again, just sort of stick with one thing at a time. Separate your clue statements, because again, you should have 3 of them. If you were working on one of them and you notice that you only have 2, there's probably a 3rd hidden one somewhere. So let's go ahead and try to get one of these figured out. Now that top one's a really good one because it has X, Y, and Z already in there. So we're going to try to do the same thing we did with the last one, and we're going to try to plug all of them so that they are all the same one. And if you look at my bottom 2, wait, this one has Z, X, and Y. So there's actually 3 in this one here. And this one has 2, right? So we probably can't do the same thing because this one had like ZY, that's 2, XY, that's also 2. So we're gonna have to do a little bit of work here to get one of them. I'm thinking we could use elimination. Now with my last class, actually, I was able to find a combination of substitution to make it work. How did I do this? And it was kind of a tricky one. I remember going over this thinking, how did I get from this step to that step to the next step? And it is possible you can do it just by moving stuff around. You can get it solved. But that's actually kind of a complicated method. So I'm going to go with something that's a little bit better. Something that is closer to what you already do. So that way it's not so confusing when you have to do it this way. So what I'm going to have to do for this one here is I am going to take this one and this one here. Excuse me. And I'm going to put these 2 together because I want to eliminate one of them. Now, I don't want to eliminate Z because my plan is that I'm going to plug it into the middle equation. So this means I have to eliminate, well, I probably should eliminate z. Now that works, but I can tell that I'm gonna have to have a whole nother one. So even though the other one was kind of tough to explain, I think it had a little bit less work. But again, it's really kind of tough because on some of these you really do have to just sort of use like problem solving to an extent that so far I don't think we've had that level of problem solving yet. And again, this one's a tricky one because there's just so many different ways to do it and none of them are really easy. So again, let's put them in the same order. So we actually have a little bit of experience doing this because remember when we were graphing, we would have to put them in the same order. So this top one can stay the same. Nothing needs to really change, I don't think. And for this bottom one here, I do want to reorganize it. So I have, okay, looking at the left side, I have x plus y. And I'm going to minus z from that side. So if I minus z from both sides, it becomes minus z. And I'm also going to have to add 4 to both sides, and that's going to look like this. And again, this is a good thing because it looks like we are going to cancel z. Okay, hold on. Let me think about this. If we cancel z, if I cancel z, we get x and y. xy equals 32. Is that going to help us out? xy equals 32. Okay, we could plug it in here, so it'd be 32 minus 4, and that would give us the number of z. But that's not going to work that well, because that would require us to know another property, but that we just haven't learned yet. All right, so I'm going to do something a little bit different. I'm going to multiply all of this by -1. And that's just going to have only the effect of reversing the sign of everything. And what this is going to do is that it's going to eliminate both of these. So at least we can get one of them. And again, this one is a tricky one, and there's just not really a way around it. I mean, I've tried 2 ways to do this, and neither of them were really easy to explain or easy to cover or easy to follow. So I'm trying another way. So 28 minus 4 would be 24. So add the 2 z's together. So 2z equals 24. So this means that the z number of metals, so that is what, bronze? Bronze is 12. At least we got 1. Is this useful for now? I don't know. Okay. Is it going to help us find the x and the y? Because if I plug it into here, it doesn't help me find the x or the y. If I plug z, I can't plug z into this one. So that's not going to help. And if I plug z into here, 12 equals x plus y minus 4. You know, add 4 to both sides. I know the number of x and y metals are 16, but that doesn't really help me out at all. But at least we got something. Okay, it's not like we just spun our wheels and got nothing. So let me think, what else could we do? We got to find x and y somehow. I got it. So we're going to plug everything into this top one here. So take the top one. So x, we know z is 12. Okay, so maybe that'll help us out. We also know that y is x plus 2. So where y was, I'm going to replace it with x plus 2. There we go. So I guess it wasn't entirely useless because now we're going to substitute this one, again, our x plus 2, just to show you where it came from. X plus 2 is this one right here. And that should allow us to get the second part. So this would be 2x plus 14 equals 28. And I'm going to have to minus 14 from both sides. So 28 minus 14, is it also 14? Yep, it is 14, I guess. And that means the number of gold medals was 7. So 7 gold medals. Or wait, no. 2 and 12. Okay, x plus 2, that's right. And then plug that in. Okay, something's kind of off. There's a plus sign back here. I don't know if that's going to, I don't know what effect that's going to have. So z is 12. Z is definitely 12. And this is x plus 2. Y equals x plus 2. That's going to be 2x. And x is equal to 7. And then plug it back into the original. And let's go ahead and plug this into the last one. And let's say that'd be x is 7 plus y plus z is 12 equals 28. And let's see, this might be easy because that would be, let's see, 7 and 12 would be 19. 19, so 28 minus 19 would be 9. And the only thing that's kind of throwing me off is, okay, so let's see, there were 2 more gold medals than silver medals. There's 2 more gold than silver. So wait, hold on, there's 9 silver and then there should be 2 more gold. Somehow these numbers got switched. Somehow these numbers got switched. All right, maybe it's a problem with our equation. There were 2 more gold than silver. I'm thinking that there's a small mistake, and that is x and y have been switched. 2 more gold. So it would make more sense if there was 9 gold and 7 silver. And the math would still add up. I think what happened is when setting it up, I changed this. I didn't change it. There were 2 more gold. So, oh, okay. So if you take the number of silver and you add 2, that should be the number of gold. Now that shouldn't really affect anything, really. I mean, I just lucked out here that I made a mistake and it still worked out. Okay. But again, I did try a whole different method of doing this differently. So x and y would be switched. So there were 7 silver because there's 2 more gold than silver. And if I add these 3 numbers up, 9, 7, and 12, I get 16 plus 12 was 28. So we still get 28. Yeah, that's right. And also 2 more gold than silver. That works out. And the number of bronze. So bronze is 12, is 4 less than the sum of gold and silver. So gold and silver, put those together, you got 16 minus 4, that is 12. Okay, good, so everything checks out. And actually, it's not really a bad example because, you know, sometimes things like this might happen, and you should go back and kind of try and figure out what's going on with all of this stuff, you know. But luckily, we made pretty good sense of it. Okay, last one. So again, sometimes it's just a really simple thing that kind of throws everything off. All right. Enrique has a pay-per-use plan on his cell phone. It's 10 cents a minute for talk, 20 cents per text message, and 25 cents a picture message. His total bill last month was $30.95. The total number of texts and pictures he sent was 87, and the cost for the use of minutes was $1.60, less than the cost of the text messages. So find the number of talk, text, and pictures used in there. All right, so we already kind of know what's going on with this one. There's three things. There's talk, there is text, and the last one is pictures, which I'll just call them pics for now, just so they're all 4-letter words. Oh, okay, so talking about the cost, so 10 cents per minute of talk plus 0, and this one's talking about all of the totals, so total of this, total of that, and 25 of this, and that came out to $30.95, and that one's kind of a tricky one, maybe because it's in two separate sentences. This whole top equation comes in 2 separate sentences, but we kind of have to use our brain to link it up because, again, all 3 of those in whatever combination add up to $30.95. All right, so the next one here is the total number of text and picture. So only text and picture. Text and picture is 87. And the cost of use of minutes, so when it says minutes, they're talking talk. The cost of the use of minutes was, so minutes, so talk was $1.60 less than, and again, less than is the tricky one because that means we're lessening it by $1.60. So $1.60 less than the cost of text. The cost. And I think this last one is going to be, it's going to have the value, because if we're talking to value, $1.60 is the value, right? That's what the number means. So since it's a value, since it's $1.60, it would mean it's not talking about the number of texts or picture messages or whatever. It's talking about the value. So the cost for use of minutes was $1.60 less than the cost of text. And okay, so hopefully that works out. Hopefully, I think this is set up. And again, sometimes if you don't set it up right, it might not work out. Okay, so you might not luck out and get them in the right spot. All right, so I have to eliminate one of these. So we could also try plugging them in, because that middle one, I could solve it for Z and plug it into the top one so that there's Y. And if I was going to try to solve it for Y, I would take that bottom one and solve it for X and plug it in, and all 3 of the top ones would be Y. So I think that's what we're going to do. We're going to plug all of them in and try to get them all set to Y. Set them to Y. So this means I'm going to have to modify this equation here. So that means this is going to be Z equals 87 minus Y. And this one here is going to be, I'm going to have to divide everything by 10 cents. So X equals, and I could easily solve this one for, I think I could solve it for Y, but then if I did that, I'd have X equals 1/2 or 1/2 X, which I don't want to deal with fractions. So it's doable. You just got to deal with fractions. And divide, okay, so 20 cents divided by 10 cents, that would be 2Y, which again gets rid of the fraction, minus, and then $1.60, 1.6 divided by 0.1, and that would be 16. 2Y minus 16. Okay, and that's not too bad. I am able to plug this and this into the top. And again, it's a little bit different because, again, y, so they both have to have y. So you're trying to solve it so that they both have on the other side the same variable. Because if I plug it in for x and z, they will be replaced with numbers that have y in them. So when I replace them with numbers that have y in them, well, okay, so that's going to make things a little bit easier because now I know that x is equal to 2y minus 16. And we also know that z is also 87 minus y. Now you notice that when I replace these, that everything is y now. So I have a y here, y there, y here. So everything is y. And again, that makes it really good to do that. Because now when I substitute it, everything should become a nice y value. So 0.2y minus, and then 16, so it'd be 1.6 plus 0.20 y plus, and then I'm going to use distributive on that 25 cents. So 87 times 0.25 is going to be 21.75, and then minus 0.25y equals 30.95. All right, and double check this, make sure I distribute it to here. This should stay the same. I'm going to hope that I didn't push the wrong button on my calculator, because that happened with my first hour. I did that and I pushed the wrong button. And luckily, one of the students was able to catch me and say, hey, you know, you made a mistake here. And that's the good thing about kind of knowing where you got things. And if you ever make a mistake, you can go back, look through your organization and see where, you know, if there was an error, where did it originate from? Okay, so let's see what we got here. So looking at the y's, I have 20 cents, 20 cents, minus 25 cents. So that's going to be 40 minus 25. It's going to be 15, so 0.15y, y. And I'm also going to have to add all my regular numbers together. So it looks like I have 21.75 right here, minus 1.6. And that's going to be plus 20.15 equals 30.95. So all I did was just combine my like terms on both sides. Combine like terms on both sides. Okay, now I'm going to have to minus 20.15 from both sides. So that gives me, this didn't change. This has not changed. And that would be 1080. And then I'm going to have to divide 1080 by 0.15, and that should give me 72. So y is the number of text messages, and that means that he would have sent 72 text messages. But at least we have the y now. At least we have the y value. Okay, so since we have the y value, let's plug it into here. So we know that this is z equals 87 minus y, but we also know, again, y is now 72. So this should help us easily get our z value. So 87 minus 72 is 15. So in this case, he sent 15 picture messages. Okay, so we have y, we have z, we're missing x. So let's plug in, right here. I think this one will work because we do know our y, we know the y value. And the y value, so that's x is equal, and I like that one because x is already solved, right? We already have x by itself. So 2y, so 2 times, well, 72 minus 16. Okay, that looks kind of like a big number. I don't know if that really makes sense. Oh well, we have no choice but to trust it now. All right, so x equals 2 times 72. 144 minus 16. So 144 minus 16, that's going to be 128. So x equals 128. So the number of talking time is 128. Now again, this is probably an old example because even though I grew up in an age where phones, well, you would only be able to talk to somebody. And even when cell phones came around, people still preferred to talk to everybody rather than text. I don't know. I think texting is just the modern thing to do now. So yeah, he probably doesn't talk this much. You know, I think these numbers would be very different nowadays. Unless, of course, maybe he's like uses his phone for his job or something. That's a possibility. If he uses his phone for a job, he probably does need to talk to a lot of people and like talk to them and make sure they get the message in a timed manner. So maybe he doesn't text as much. So, like, but again, I think this example is a couple of years old. I think it was printed in like 2015, 2014. So these are like 5 or 6 years old examples. But again, I think it would be a lot different nowadays. So there we go. We have his talk, his text, and his picture messages. And that is it for this one here. So I think we are done. Okay. And that's it for today. Hope you enjoyed the lesson. So thanks for showing up. Bye-bye.